Hello, we are going to look at section 7.3 today, which is the last portion of chapter 7, and it involves solving equations of exponential expressions. So the first thing that we're going to look at is a skill that you're going to need in order to solve equations, and that is changing the base of a power to being a common base. And so in this case, we're going to look at a base of 2. So if we look just at 4 cubed, that's the same as replacing 4 with 2 squared, still to the power 3, as we're just replacing the 4 with 2 squared, and the 3 remains. And then using your exponent laws, a power to a power becomes 2 to the power 6. So those two things are equivalent. Similarly, if I have 1 over 8, that's 1 over 2 cubed, because 2 cubed is 8, and when we have a power in the denominator, it's the same as having the negative exponent in the numerator. So these two expressions are the same. And then things get more complicated, as you can see here. Often with more complicated expressions, things work out nicely and kind of cancel out a little bit. Here I'm just changing 8 to being 2 cubed with the 16. That's 2 to the power 4. So that's the 16 underneath the root sign, and a root sign can be written as a power of 1/2. So I'm going to apply that root as a power, and that's still all to the power 3. So when I start simplifying powers, multiplying them together, 2 cubed to the power 2/3 becomes 2 squared. Think about that. 2 to the power 4 to the 1/2 becomes 2 squared, and still to the power 3. So now I get 2 squared times 2 to the 6, and now same base, I add exponents. The answer would be 2 to the power 8. Those expressions are equivalent. And the reason we're going to use that skill is, what if we end up with expressions like this? And these we can actually graph one side and then graph the other and see where the point of intersection is. That's how you check your answer using the graphing technology. We're just looking for the point of intersection. We also want to be able to do it by calculation. So the first thing is we're going to compare the bases, in this case 2 and 4, and the common base of 2 and 4 is 2. So I'm going to leave the right hand side the same. I'm going to change the 4 on the left hand side to being 2 squared, and that's still to the power of x plus 3. Then I'm going to multiply the powers on the right-hand side. And then here's your logic. If the bases are the same and they equal one another, then the powers must also equal. So in the next step, we're not getting rid of anything. We're just saying logically that the powers must equal one another. And then when we solve for x, we find the answer is 3. When you graph these two expressions, they will intersect at 3. And that's the basic lesson. Again, I'll just do another one here. I changed 9 to 3 squared. I changed 27 to 3 cubed. So you're going to have to practice recognizing what the common base will be. And then it's just a matter of making your exponents equal to one another. So again, here I kind of skipped a step, but the power must equal the power. And then we get x by itself. And here we get a fractional answer. Again, that's the point, the x value anyways, where the graphs are going to intersect. And the rest is just basically practice. You'll see there's some problems you're going to have to apply it to, but you can handle that. Your assignment's going to be as follows. If you want to start it now, you sure can. Otherwise, we'll work on it in class, or you'll have to get it done for homework. That's it. I'll see you next time.